Welcome to Module 2, Graphing Trigonometric Functions. It's important to review the standard trig curves before discussing stretches and shifts of these curves. We will first start with the sine wave. The general form of the trig equation for sine x is f of x is equal to a times sine of b times x plus c plus d. The constants a, b, and c determine the period, amplitude, and phase shift of this function. We will discuss these attributes of trig functions later in the notes. Here are two graphs of the sine wave. F of x is equal to sine x. Both of these graphs are of the same curve, except for the graph on the left shows the x-axis being labeled with ordinary numbers, whereas on the right, the graph has an x-axis that is labeled in terms of pi. You can see from both graphs that our sine function starts at 0. So the point at 0 and the y value is also 0 for the sine wave. The period of the sine wave, which we will define more later, is 2 pi. So you finish one full cycle in 2 pi units. And we know that 2 pi, if you evaluate it on your calculator, is roughly 6.28. The zeros of the sine wave are 0, pi, 2 pi, and so on. So every integer multiple of pi. Recall that we can write these zeros in set notation as a set of values, k times pi, such that k belongs to the integers. Now we're going to examine the cosine wave, which in general form is written as f of x is equal to a times cos of b times x plus c plus d. There are two graphs shown here to represent cos of x, and just like the previous example with the sine wave, the graph on the left shows the x-axis in ordinary numbers, and the graph on the right shows the x-axis in terms of pi. Our cosine wave also starts at 0, but the value of the function is 1 when x is equal to 0, and one complete period is also completed in 2 pi. Although the period of the sine and cosine functions are both 2 pi, the zeros occur at different points. The zeros occur at pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, and so on. Expressing this in set notation, we get the odd numbers, so 2k plus 1, divided by 2, multiplied by pi, such that k, the constant k, is an element of the integers. This may be your first time seeing odd numbers listed as 2k plus 1, so I just wanted to sort of show you what that looks like. So for various integers, such as, let's say, k equals -1, 0, and positive 1, the values of 2k plus 1 that you get are going to be, so -2 plus 1, which is -1. When you plug in 0 for k, you're going to get positive 1. And then when you plug in positive 1 for k, you get 3. So you can see how you end up getting only odd numbers, because 2 times k is always even for any integer k. And when we add 1, that forces it to be an odd number. Now that we've discussed a little bit about the standard sine and cosine curves, let's discuss some more attributes of these curves.